Okay, hello everyone. I usually start the class. By now you should kind of know how I start the class by asking 2-4 questions. Do you have any questions before we get going? Please either ask them, unmute yourself and ask, otherwise put your question on the chat and I will take care of that. Okay, I'll give you like 30 more seconds.
Can you hear me?
Yes, yeah, I think I can hear you. What's up?
All right, so in 1.1, number 25.
Yes.
Are we just supposed to like really solve the equation, or like what other steps should be done?
Number 24, okay, we can do that because you will be doing number 24 in 1.2.
25, I think it was, is one of G, H, and K.
So that's 1.1 then.
Yeah.
Okay, let's have a look at this one. And so number 25, section 1.1. Okay. So we have the augmented Travis system. And so we have a system initially. And they give us the augmented matrix of the system. So instead of giving us the system, as you realize, they just give us the augmented. 1, -4, and 7. And 0, 3, -5, and H, -2, 5, -9, and K. All right. It means in the back of our mind, we have actually a system here. We have some kind of a system. So that's a system of 3 equations. So that's really what we have here. And 3x2 minus 5x3 is H, and minus 2x1 plus 5x2 minus 9x3 equal to K. All right. And in this scenario, G, H, and K are just parameters. They didn't give it to you. But the question is, what condition should those parameters satisfy? So what equation should relate them? So the result, so that this system will be consistent. In other words, for some values, the system will be inconsistent, and for some, it will be consistent. And the question is, which one will give me inconsistency? Are you okay? Is that clear? So how do we solve those type of problems? We solve them like we solve any system, and then we ask ourselves what can cause a problem. So we solve. Now how we solve, we again start and we go to the echelon form. So I start with this, I go to the echelon form. So to go to the echelon form, I have to create a leading in the top spot, which is I have, it's a 1. And I use it to make under it everything below it is 0. This is a 0, so I am safe in here. I want to make this into a 0. So I need to multiply the first row by a 2, add it to the last one, and this would be my new row 3. Okay, so let's do that. 2 minus 2 is 0. Please, if I do any computational mistake, you have to correct me. Minus 8 plus 5, that's a minus 3. 2 times 7, that's a 14. 14, you get a 5. And now this G should not really bother you. It's just like a number, but they used a letter for a number. So this should be what here? What should I write here? Put it on the chat quickly.
2G
2G
plus K.
plus K. Okay, now we are solving. It means exactly what we're doing is but like the same way we solve. We keep going till we hit our echelon form. So I guarantee everything below it, I move to the right and I move here. And I have a leading, so I am in a good shape. Now I have to use it to make this into a 0. And this is an easy problem because there isn't really much to do in here. I just had to add the row 2 to the third row, and what I get, this will give me my third row, okay? So this will end up being a 1, it's a minus 4, 7, and a G, a 0, 3, minus 5, H, 0, 3 minus 3, it's a 0, minus 5 plus 5, it's a 0, sorry, and then I am just adding. So this term right here is going to become in H plus 2G plus K. So I have to do that, okay? That's leading. And I really stop when I am hitting some kind of, not some kind, that I'm hitting my echelon form. So I have a leading here. So usually I move here and go down, but I have a 0, that is nothing. Then I move here and I have H plus 2 plus 2G plus K. So now the question is, find an equation that relate those that will make the system consistent. So under what condition, what's the equation that should relate those variables which will give me a consistent system? Consistent system. So what should we know about that?
It needs to equal 0.
If this is equal to 0, do you agree? I have that. Do you agree with that?
Yeah.
Absolutely, because if this term is non-zero, it means if I had a pivot in here, I have a non-zero term in here, then I will have 0 equal non-zero term, which give me an inconsistency. So the system is consistent if H plus 2G plus K is absolutely equal to 0. That's what will cause the inconsistency. If this term is not 0, then I will have 0 equal non-zero term. The system will have no solution. So now I have the condition. So now if I tell you, give me a value of GH, so the problem is done. That's really the equation that I'm looking for. So now if I ask you something, give me one value of H, G, and K such that the system is consistent. So give me a value of H, G, and K that force the system is consistent. So it means, what can I write here? One scenario, so that when I plug in, I'll have a consistent system. So I'll write up the equation in front of us so we can see it. That's the equation. So give me a bunch of numbers that make the system consistent, quickly.
You could do -2 for H.
-2 for H.
1 for G.
1 for G.
And 0
So
for...
let me see where we are here. G, you put 1, -2.
And 0 for K.
0 for K. That's one possibility. So if I put 1 -2, 0, I will have a solution. If I put 1, 0, 0, I will not have a solution. So this really, so we have a system where the right term can take different values, and the question which will guarantee consistency and which will cause non-consistency. All right, any questions about that? Now the other
Thank you.
question, go ahead, I'm listening.
I was saying thank you for doing that one.
What?
I was just saying thank you for doing that one.
Oh, sure. Number 24, what is it? Okay. Now, number 24, section 1.2. So to do the number 24, which is we will do now, let us go a little bit over the worksheet that we did last time. So this will actually complete the whole discussion, because next, at the end of the hour, I'm going to move to something very different. So I want to totally finalize the discussion about system. So I'm going to look at number 3. This is the worksheet that I gave you. So all of you should have it last time. And I want quick answers to everyone, so we understand totally the picture of the system. So describe the echelon form of the augmented matrix of a 3x3 system in each of the following scenario. So 3x3 system, it means the augmented should have, so 3x3, it needs 3 equations and 3 unknowns. So the augmented should be like that. And my question is very easy. I want the system to be inconsistent. Describe the echelon form of the augmented. So please get going. We should go through that fast. Okay, who would like to answer this? Don't make me pick. I don't really know you, so I really don't want to be mean. What should I put here? Using those symbols quickly.
You could put the square,
I put the square.
and you could put a star, another star, and then yeah. Then you could put a 0, leading the square. Then a star and another star. And then 0, 0, leading the square. Oh, wait.
Oh,
Inconsistent.
yes.
Inconsistent. So 0 instead of the square.
We have to have a 0.
Yeah.
And then
star. There's leading.
no.
Not a star?
No. Why not a star? Why I will refuse that? Who can give me the reason?
Because a star can be any number.
Exactly,
It could be
because
a
the star
0.
can be any number. The star can be a 0. And if this is a 0, I don't have inconsistency. Is that very clear?
Okay.
I have to 100% make sure this is not a 0. Star is allowed to be a 0. This will have to be a non-zero term. That's what leading means. It's not 0. Okay, that's how the inconsistency for the 3x3 system occurs. So now this is inconsistent because the row, this row reads 0x1 plus 0x2 plus 0x3 equal something which is not a 0 number. That's the picture for inconsistency. Okay, very quickly, I want B. Again, I want the system to be consistent with infinitely many solution. So what causes infinitely many solution? What causes infinitely many solution?
Free variable.
Free variable. So we have to really build up how the augmented matrix should look like to guarantee that we have a free variable. So who can give me the first row very quickly?
Square.
Square. Keep going. Keep going.
Another star. And then a star. 0, 0, leading, star, 0, 0, leading. Or sorry, the last 0 is supposed to be a leading.
Oh.
And then a 0.
Okay.
Is
this in echelon form?
No. No, it's not.
Is this in echelon form?
No.
And the answer is no. Why this is not in echelon form? In echelon form, what should happen? Everything below a leading has to be 0. So we have 2 issues. So everything below a leading has to be 0. In your scenario, this is a leading, but this is not a 0. So this scenario, this is not in echelon form. Okay, because that's not the form of the echelon form. All right, and so according to you, the system doesn't really make sense, because according to this picture, X3 is 0. And if I back up, X3 is something else. So there is an issue with this scenario. I can't accept it. So fix it. How can you fix it?
Just make the bottom row all zeros.
Right. Since there is a leading, this has to be 0. Otherwise, it's not an echelon form. And if I want it to be consistent, I have to avoid a non-zero term here. This will have to be a 0. That's the picture for consistent with infinitely many solutions. Okay, so let me go back to the first scenario, because I want it to be clear why it is not right. So, and I want to put numbers here. Suppose I imitate the previous scenario. Let us say 1, 2, 3. So I want to be convinced that this is not working. And let me put this as a 4. So 0, 0. Suppose I put 1 and 2. And suppose 0, 0. And I put a leading here and 0. What can you say about this system? Does this system have infinitely many solutions? It's a 3 by 3 matrix. Question addressed to you. This system here, it's absolutely an inconsistent system. This system does not have infinitely many solutions. Why it is inconsistent? I'm going to give you 2 reasons why it is inconsistent. The first reason is if we read it, how do we read that? X3 is 0, X3 is 2. So I cannot have X3 to be 0 and then have X3 to be 2. It's not free variable. So I'm not telling you X3 free, I'm telling you X3 is taking those 2 values. So this doesn't make sense. And then if I go to the echelon form, this is going to be 4, 0, 0, 1, 2, 0, 0. That's a leading. Minus 1 plus 1, it's a 0. And this is minus 2. This is absolutely an inconsistent system. Okay, so infinitely many solutions, and that's important. To want infinitely many solutions, it's not only a matter of having a column without leading. We need 2 things. We need a column without leading, and we need consistency. So we have
Professor?
What?
I know a lot of students are saying, is this supposed to be a 3 by 3 matrix or
yes.
3 by 4?
A 3 by 3 system. If the system is 3 by 3, the augmented is going to be 3 by 4.
Oh, okay.
Is that clear? All right. So I go back and I tell you, to be infinitely, we have to 1 column to the right of to the left of the last column should not have a leading, but at the same time, I need consistency in the system. So that will be picture for consistent and infinitely many. And now C, I want consistent with unique solution. I'm still in the same, how is the picture looks like? Is it possible for a 2 by 2 system that is consistent with infinitely many solution? And the answer is absolutely yes. Do it. Think about it. Okay. I want a unique. Quickly, what is the picture?
Square.
Unique, it means we have to have each one of them basic. So every variable, x1 now it's a basic, x2 is a basic, x3 is basic. That's the scenario for a unique solution. And there is no free variable here, and we don't have issue with consistency because this row read, this is not 0. So let us say it's a 2. This would read 2x3 equals something. I can solve for x3, back up, x3 I have it. I can figure out x2 because that's a non-zero number, and then I can figure out x1. So that's the picture for a unique solution. Okay. Now I do number 4, and then I address the question that's on the chat. I have the same question, but now it's a 3x4 system. If a system is 3x4, it means 3 equations and 4 unknown. 3 equations, 4 unknown. So the augmented matrix in this scenario should be a 3x5 because I have 4 unknown. And now I ask the same question as before. So I will go through all scenarios. A, how should it look like to have inconsistent? Okay, who wanna give me the second line, please, very quickly?
0, leading, star, 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 0, 0, square, star.
No, it's 0 and then square.
Oh, inconsistent. My bad. I thought it was the same question as before.
No.
0 and then square.
So finish the last row quickly.
0, 0, 0, square, 0. No. Yes. Let's go.
Is he correct? Yes or not?
Don't you?
Yes.
Does this give me inconsistency?
No.
Yes.
I
All
would
right.
say 0 square.
Absolutely not. Why?
Oh, it needs to be 0. It needs to be zeros. All across the
Because
box.
if I plug in number, suppose leading, it means non-zero. Let us say this number was 10. How will this read? 10x3 equals 0. It means x3 equals 0. I don't have any issue. The only way we can have is this is a 0 and this a non-zero term. That's inconsistency. Is that very clear? Don't flip them around. Try to understand what it means. If I have a 10, a non-zero number, and I have 0, this means 10x3 is 0. It means x3 is 0. I don't have an issue. I have an issue if I have a 0 and a 10, because this would read 0 equal 10. That's where the inconsistency is coming from. Is that very clear? Now B. I want it to be consistent, and I want it to have infinitely many. What is the picture? Very quickly. Consistent, it means I need to avoid the scenario. I'm not allowed to have leading in the last column of the augmented. That will guarantee the consistency. Infinite, it means I need one of the variable to be free. So 0, that's one scenario. And here, I don't want a leading here. So the leading has to be to the right. So now I can have a leading here. This has to be 0 because that's my leading. This has to be 0 and this has to be 0. Is this infinitely many solution?
Yeah.
Yes,
Yes.
because x3 will be free. Okay? No, it can be 0. Yeah, no problem. Okay, now my last question here. Same question, it means if I have a 3x4 system, can scenario C occur? Can we have a unique solution if I have basically more unknown than equations? So if I have more unknown than I have equations, is it possible to have only one solution? That's the question.
No.
Okay, so my question now is, suppose you have 3x4 system. It means I have 3 equations and 4 unknown. And if the system is consistent, so I'm not really having problem with that, can the solution be unique? That's an important result we should know. Can the solution be unique? Yes or no? Justify. Think about the echelon form when you try to justify those ideas. Okay? So I'm expecting answers. So I want a 3x4 system. I want it to be consistent. It means no leading here. I cannot have this one because I want consistency. So this is, have to go. And the question is, can it have the unique solution? Noah is telling me no. Can you tell us why no? And the question is no. We have to have infinitely many. Why do we have to have infinitely many? Are we going to have necessarily a free variable in this situation? Yes or no? Let us think about it. What's the maximum number of leading can we have in this case?
3.
What's the maximum number of leading we can have?
3.
3, because we have 3 rows. So the maximum number of leading is 3, because a row cannot have 2 leading. The leading is the first non-zero term. So the maximum number of leading is actually 3. We cannot have more than 3 leading. So, and we know that there is no leading in the last one because I have consistency. So what does the picture mean? It means, let's say this is the column that corresponds to x1. This is the column that corresponds to x2 that has a leading. And that's one scenario. And this is the column that corresponds to x3. I'm done. That's the maximum number of leading. It means one of the variable, the column that corresponds to one of the variable cannot have a leading. This variable will be a free variable. So the maximum number of leading is 3. It means the column, since we have 4 variables, it means that the column that correspond to at least 1 has no leading. That correspond to at least 1 variable has no leading. So I repeat, because at most we have 3 leading, because we have 3 equations, but we have 4 variables. It means one of the equation, let us say x4 in my picture, there is no leading here. It means x4 will be free variable. So since that corresponds to at least 1 variable has no leading, it means that at least one variable will be free. At least one. And because it is consistent, I'm giving it to you, then the free variable will generate infinitely many solutions. So let us a little bit summarize what I am saying here. If you have a system, crucial, where the number of equations is less than the number of unknown. So we have less equations, so we have less restriction on the variable than we have variable. Then if the system is consistent, we have infinitely many solutions. Okay, and this is one of the problems that we have that I gave you. Okay, so if system is consistent, suppose system consistent, and that's crucial, means there is a solution, and the number of equations strictly less number of unknowns. This forces a free variable. This forces a free variable. Hence, we have infinitely many solutions. Infinitely many solutions. This type of system is called indeterminate system. This system where the number of equations less than the number of unknown is indeterminate. And usually to be able to understand those questions, always ask yourself, how the echelon form would look like. And this really guides us into the type of solution. Any question before I move on? So let us a little bit, all this is on your worksheet, so you guys have it. Let me summarize now the existence and uniqueness of a solution, okay? So we have any system. The system could be consistent or not. If it's consistent, we can have either unique or infinite. So a linear system is consistent if and only if the rightmost column is not pivot. What does it mean? If and only if the echelon form of the augmented does not have a row of the form 0, 0b, where b non-zero. So it's consistent if this scenario is avoided. It means we cannot have, the last column cannot have a non-zero term, cannot have a leading. If a linear is consistent, it means if this satisfied, then we can have either unique or infinite. When do we have unique? To have unique, every variable has to be basic. It means the column that corresponds to every variable should have a leading. So a unique means there are no free. It means this occurs when every column, of course, to the left of the last one, every column has a leading entry. So to have unique, once we avoid this, every column has to have a leading, because then I can do back substitution and solve very easily. Infinitely, when there is at least one free variable, it means one of the column has no leading. I change, sorry. Something like that. If one of the column has no leading, then I will have infinitely many. Okay, so the echelon form will actually tells me everything about the nature of the solution, whether it's unique, non-existence, or infinite. Okay. Now one of your classmates asked me the following question. I'll address it before we do the last problem, which is I will end this two section with. One of your classmates asked me the following. Can a 2x2 system, can a 2x2 system have infinitely many solutions? It means, can it do, yeah. So who would like to answer him? So that's on the chat. Is it possible to have a 2x2 system that is consistent with infinitely many solutions? What would be your answer? Yes or no? Yes, justify. No, justify.
I believe yes, because you would make the bottom row of the matrix all zeros, leaving you with just a linear equation that would be a line representing all the points on the line.
Exactly.
So
exactly.
infinitely many points on the line.
Right.
And that's the only thing that we have to resolve.
Okay, so let us say you have this equation equal to 4. Okay, that's one. And let us say I do the other one. And basically what I'm going to do is the same equation, which is written slightly different. So I'm going to multiply across the board here by 2. That's my system, okay? And when I go to the echelon form, so those are basically two parallel lines. That's really what I'm having here. So now when I go to my echelon form, what the row reduction does for us, it actually gets rid of the redundancy in the equations. Now, this is a simple problem where the redundancy is clear, but when you have a lot of equations, you don't see the redundancy. You don't see that some equations are repeating themselves, or you don't see that one equation is the sum of two others. The echelon form gets rid intuitively of those redundancy that occur within the system. So if I go here to the echelon form, minus 2 plus 2 is a 0, minus 4 plus 4 it's a 0, and that's a 0. So this is obviously a consistent system, but this is a system with infinitely many solutions, because this is basically one line. So every possible scenario can occur, all right? Okay, now we finished this part. Okay, we finished this part with the last problem, which is very much like the first problem you guys asked me to, but with slight variation. So, and I would like you to work with me on that because those problems, again, come up with us a lot. So this is a system where I am allowing, so it's a system to equation to unknown. I wrote X and Y just to make it easier for us. And in this problem, I'm telling you what are the unknowns. X and Y are the unknowns for us. And H and K are parameters. And the idea is that when I start changing the value of the parameter, the system changes, of course. So if H is 2, K is 5, is different than H is 5 and K is 2. So the parameter change. The question is, which parameter will allow one solution, which will allow two infinitely, which will make the system inconsistent? All right, so that's the tough question we're answering right now. Now, the first question is, find the echelon form of the augmented matrix of the system. Any time we have to discuss the solution, we use the echelon form because it's really tell us the whole story. So first find the echelon form of the augmented. So step number one is we have to write the augmented system. So what's the augmented? It's a 1, -3, 1, 2, H, and K. Find the echelon form. We should not let, as I did previously, parameter really have any effect. So this is my leading. I'm gonna make this into a 0. So we'll do that. So to do that, I should multiply the first row by a 1, add it to the second row, and I want this to become my new second row. Okay, so what should I get? -2 plus 2 is a 0. What should I get here?
6 plus 8.
Put it on the chat. Put your answer on the chat. What?
Is it 6 plus H?
It's 6 plus H, exactly, because it's -2 times -3, which is a 6, plus H. Don't let H, it's like a number. And finally, this is a 1, -2 plus K, -2 plus K. That's the echelon form. I did not ask you to reduce. I would ask you to reduce. I would have, but this problem, usually echelon form is the way to start. So this is my echelon form. And now the echelon form really helped me to figure out everything. So this problem is based on what we're talking about. Which values of H and K will make the system inconsistent? So we have to remember, how can a system be inconsistent? And then answer these questions. Okay.
The bottom row
If
H
6,
is -6 and K not 0. Okay, yeah, the answer is correct. What can cause inconsistency? We know. Everything here we have two equations. So anything that looks like that, if the matrix has echelon form, have a row like this causes inconsistency. So what's going to cause the inconsistency is every value that make this 0, but this one not 0. Okay, so it's inconsistent when 6 plus H is 0 and -2 plus K non-zero. Because in this case, the last row will read, because if this happened, the last row will become 0, 0, and a certain B where B is non-zero. That's really what causes it. So which value? H is -6, K different from 2. End of the problem. Okay? Now, which H and K, again, is the echelon form that you go after. It really tells us the whole story. Which A and K will cause the system to have only one solution. So you have to remember how a system, it's a 2x2 system. If you want a unique solution, what should the echelon form be? If you want a unique solution, of course, you want the system consistent. And you want a leading for here. No, sorry. You want a leading from here for here. And here you don't care. Any number will do. It doesn't really matter. So now this is the picture for a unique solution. What conditions here should be satisfied to guarantee that? Anybody? K cannot be equal to -6. Do we agree? Sorry, not K, H. Do we agree with Bryce? Let's see.
K has to be -5.
Let's see.
H, sorry.
Right. The only condition
H.
I need is on H. So X1 is definitely a basic variable because there is a leading in the column that corresponds to X1. So my problem is really here. My problem is really for the column corresponding to X2. So to have a leading here so I can solve for X2, then I need H plus 6 has to be different from 0. Otherwise, I will have 0 here and H plus 6 different from 0. In this scenario, both variable X1, sorry, X that we call them, in this scenario, X and Y will be basic. We don't have any free. And the system is consistent. And the system is consistent under this condition. So, and the condition guarantee the system consistent. Why? Because I always have to worry about consistency. And the condition guarantee system consistent. Why it guaranteed? Because if this number here, if this leading is not 0, of course, I cannot have a leading here. End of the story. So the condition should be H. To have a unique solution, H has to be different from -6. And I will take 2 minutes, even though I did not ask you. Let us solve the system. So in this condition, let us solve it. Let us solve the system under this condition. So this is my echelon form. And let us solve this condition, the system. Okay, even though I didn't ask, but I can ask another time. So let us solve it. How do we solve it? This is leading and this is non-zero. So to solve, I immediately write the equation that corresponds to this system. What's the equation? This one read, be careful how it reads. 6 plus h times y equal -2 plus k. Be careful, y and x are the unknown. Those are just parameters. My first one would read this equal to 1. So to solve here, I need to do back substitution. So my y would be -2 plus k over 6 plus h. So my solution will depend, of course, on the parameter. And watch, I can divide by 6 plus h because my condition is h plus 6 has to be different from 0. And my x is easy. My x is, by back substitution, 1 plus 3y. It means is equal to that. And the rest is a simple math that you should be able to do. So the solution is unique because that's not 0. I was able to solve it. And when I backed up, I was able to solve for x. Absolutely unique solution. And then the last one, and we finish. For which value of h and k does the system have infinitely many solutions? And explain. So I want infinitely, and I want to make sure I have consistency at the same time. So how can this occur? Let us imagine the echelon form. How should it look like? Who can tell me how the echelon form should look like using the boxes and stars so that I have infinitely many and I have consistency? How should it look like? I have leading because it's and star and star. And to have infinitely many, since this is x1 cannot be a free variable because the leading here is 1, x2 will have to be. So x2 should not have a leading. So I can guarantee x2. Very good. What should go here?
Can't see it.
I'm sorry. Thank you very much. Please
You're
let
okay.
me know when this happened. What should go here?
0.
0. Why? It has to be 0.
Because otherwise it'd be inconsistent.
Exactly. So the echelon form should have that format. So this is my leading and anything, star star. This is a 0 because I'm in echelon 4. In this here, I need 0 here because I need this to be free because x cannot be free because x is 1 in my problem. So this has to be free to guarantee infinitely many, but I need consistency and that's crucial. This has to be 0. And now I go back to my echelon form and I ask myself, under which condition this should occur? So I write my echelon form down here so I don't have to keep the paper up and down. So that's a 1, 0, 6 plus h, and minus 2 plus k. So what condition should be? Quickly.
H has to be -6 and
Right.
K has to be 2.
6 plus h has to be a 0.
So H has to be -6.
Yes. H
And-
-6. And the and is important.
And K has to equal 2.
Absolutely. Minus 2 plus k has to be 0. K equal to 2. And now let us explain everything. Why do I need minus 2 plus k to be 0? This will guarantee what? All of you, at least say it in your head. This guarantee consistency in this scenario, and this will guarantee my free variable. Because free variable without consistency doesn't really make sense to us or whatsoever. All right? Okay, so for today, I stop right here. I'll give you a lot of time for your quiz because that's the first time. And with this, we are going to assign more problem along those lines for next time, for Wednesday, next Wednesday. Please make sure you do them. And starting Wednesday, we're going to basically switch. We're going to talk about other things. What we developed so far, as I said, those are the technique that I will be using all through the semester. And as you will see, I will always come back to those in a different context. All right, so now it's time for the quiz. It's relatively simple. So let's see how you guys are gonna get the quiz. I want you all to go to Brightspace and I will share the screen with you. At least I will try. It's very easy. So all of you go to Brightspace. Okay, let me see. I am in your course. And okay, I'm gonna also go to the student form, like that's what you guys see. You go to content, all right? You scroll down to quizzes, you click on quizzes. Mine is clicked before. Then you go to quiz 1. And I told you, please print the quiz. You don't have to, if you don't have it printed, doesn't matter to me, or just to write the answers very clearly on a sheet of paper. Order your number well. When you're done, upload it into Brightspace as a PDF and hit submit. So now when you click on quiz 1, then you go here. The quiz is in front of you. So the first question is just row, reduce the matrix. I will judge you on writing the steps clearly. The second is row reduce, to reduce echelon form. So I gave it to you in echelon form. I wanted to do reduce echelon form. And the last question is solve the system. Okay, so you have to make sure, tell me what are the free variable, what are the basic, and to write the solution, all of it. When you're done, you upload into Brightspace and you hit submit. I will be with you during this time. Okay, get going. And if you have any questions, you put them in chat for me. You don't, speak up.